Maximum inputs for creating this video tutorial have been taken from a tutorial which is available at the Scripps Research Institute. Okay, so we suggest downloading and installing these 5 softwares for molecular docking simulations and analysis. The links have been provided: Discovery, Python, MGL 2154, Autodock, Suite, and MOL. First of all, we need to install Python for normal working of MGL Tools 154. We have downloaded all our softwares in D drive. Install the softwares in default locations. Now install MGL Tools. Okay, so this is the final window which pops up if everything is normal. Installations are complete. Next is to install Autodock 4.2 Suite, and it is to be remembered that this software should be extracted and installed in MGL Tools 154, which is located in program files of C drive. So these are the contents, these 3 files are the contents of Autodock Suite. 2 are applications, AutoGrid and Autodock, and 1 is a JUN file which is required for the normal working. Similarly, you could also install other softwares such as Discovery Studio and MOL. Now we are all set for this tutorial. The first step is to download a protein which is 1HSG from RCSB protein database, and the website for this protein data bank is pdb.org. You need to type in the PDB ID 1HSG of the protein. This protein is a complex of the ligand indenavir with the protease. Now, after downloading this 1HSG protein, we need to see this, view this in Discovery Studio. We need to look into the protein ligand interactions, and the most important thing is to form 2 files, one for the ligand indenavir and the other is for the protein, which is a protease without the ligand. So here we can see the interactions, the ligand indenavir with the binding site residues in the protease. You can label the residues and we can make sure which are the residues which are interacting with the ligand indenavir. Okay, so now we are again going to upload this protein, and the main object now is to take out the indinavir from the protein. So we are going to select ligand and then we would delete it. So now this is a protease without the ligand. Save as in the folder MGL tools 154 with the extension .pdbqt. Again we would select ligand, but this time we would invert the selection so that the protein gets selected and then we delete the protein and we are left with the ligand. Now we are going to save it in the PDBQT format again in MGL tools 154 folder. Both the files should be with the extension .pdb. Now the second step is to ensure we have to start the Autodock tool, but before we start we need to ensure that the Autogrid, Autodock and Sigwin executables, they are in the MGL tools 154 and the separated protein 1HSG with the extension .pdb and ligand with the extension .pdb, which has been created by Discovery, they are also present in the MGL tools 154. And the important thing is to run the Autodock tool, which is a Windows batch file from MGL tools 154 folder only. Now we'll go into the folder MGL tools 154 and you can see ADT batch file, double click it. Okay, so the first thing is to upload the 1HSG protein. This is a widget. There are a lot of options that you can try. We need to add hydrogens into the protein. Now we would save as this protein after the processing into a PDBQT file. Again we are going to input the ligand with the PDB extension. The GUI gives us some characteristics of the ligand indinavir. We need to detect the root and choose the torsions, and if required you can fix some bonds as rigid, or there is also a choice to make some bonds as flexible. Here we are taking the inputs that have been given from the text tutorial from Scripps Research Institute. After this, we are going to save this ligand in PDBQT format in the folder MGL tools 154. As per the tutorial, we are going to make arginine 8 as the flexible residue. So need to go into select from string, type in arginine 8, and the GUI shows us that 2 residues have been selected. Zoom and click on the bond between CA and CB in both the residues. Close the box. Now we are going to save a flexible residue file in the PDBQT format. And another file we are going to save, which is a rigid file for the protein in the PDBQT format. And both these files will again go in MGL2's 154 folder. We should remember that the docking actually is done on the rigid file. Now we are going to choose the grid box. This will tell the software where the binding site is present for the protease, and for that you need to choose the protein. If it is not present in the widget, then you need to open up the protein from MGL2's 154. Similarly, you need to choose the ligand also, and then this is a small grid box options window. There are some dials. You can freely move them, and you can move the grid box in whole of the protein. Exactly, the grid box should be in the area where the ligand indenavir was sitting, and you can move this grid box by moving the dial on the grid options window. One thing to remember is that the ligand should be able to be in the grid box in its extended form. Now to close this window after saving it, and all the inputs would be saved in a GPF file, which again would be saved in MGL2's 154 folder. You can edit GPF. At times it is required that some map types are missing, and you can type in those map types. And can overwrite the GPF file which is present in MGL2's 154 folder. After editing the GPF file, you need to click write option and then overwrite on the previous file, on the previous GPF file. Okay. Now just check in the MGL tools folder whether all the files Autodock 4, Autogrid 4, and the ligand.pdbqt and the flexible and rigid files are present. All the input files should be present in this folder only. Otherwise, the software Autodock or Autogrid will not process and will stop after giving an error. Okay, we need to start Autogrid now. Launch, and here the Autogrid software starts and will generate the map files that we have specified in the GPF file. A message pops up, successful completion, which tells us that the calculations have been done completely. Now, to start the Autodock, first we need to choose the rigid file, and we have to specify the flexible file also of the protein. We need to choose the ligand also, accept the default parameters, go for short, accept, marking genetic algorithm, and save the input parameters in a file with extension .dpf, again in MGL Tools 154 folder. This is how we can edit DPF file if required. Okay, now we are going to run Autodock. Launch. Completion of the calculation is marked by the message successful completion. Now the calculations have been done, and we are going to analyze the results. Go to dockings, analyze dockings, and open up a DLG file. Now these two residues that you are seeing, one above the ligand indenavir and below it, they are the flexible residues. This is a pop-up window which gives us the binding energy and the binding affinity of a particular bioactive conformation. Here we are choosing the fourth bioactive conformation. You can also see the other conformations by changing the right arrow and the left arrow. If you are interested in saving the complex of the protein along with the docked bioactive conformation, then click on the ampersand and then choose the macromolecule and then click on the option write complex. This will pop up a browser window and you can save it in any destination as you like in the file format of PDBQT. So here we are done with the MGL tools, Autodock tools. We close it and now we would open PyMol and visualize the complex that we have saved. This complex is of the protein protease and the docked indenavir ligand. Okay, go into action A and then into preset ligand. So this is the zoomed view of the docked ligand indenavir, which is sitting in the binding area which was provided by us in the grid box. You can name the residues also here. Now we are interested in overlaying the docked indenavir structure and the crystallized indenavir structure which was present in the protein which was downloaded from the site pdb.org. Now overlaying these two structures over each other would tell us whether the simulations have been done in a fair way, although we could change some inputs also. Here you can see the two overlaid structures and results of the final molecular docking could be improved as per your requirements by modifying the inputs, which are ligand torsion, and amino acid and ligand flexibility. You can play around with grid box settings or other default parameters. All these inputs are needed while preparing for the simulations. So basically, you could do some modification in processing of the protein and the ligand. We changed the inputs and this is the structure, this is the overlay that we received. You can see they are exactly overlaying over each other, the docked indenavir from our simulations and the real bioactive conformation of indenavir which was present in 1HSG. So this tells us that the simulations were done in a very fair way. You can save the image of this overlay structure and you can also view the chemical interactions between the docked indenavir with the binding site residues, and you can match with the ones that are present in the protein 1HSG which was downloaded from the protein data bank. And you can compare whether the simulations were carried out in a correct way. So this is all. Normally some errors creep up during ADT execution, and the first one is the file format unknown and can't parse it, and the second one is I can't find or open one rigid.hd.map, which we have taken care of in the tutorial. Thank you for your time. Bye.